today's session. So last time, if you remember, hopefully लाडू चकल्या करंजा खाऊन विसरला नसाल तर आपण फिफ्थ युनिट चालू केलेलं. फिफ्थ युनिट इज अबाउट द बॅक ट्रॅकिंग, राईट? सो हाऊ वॉज द दिवाळी? दिवाळी कशी गेली? एन्जॉय केलं?
Yes, ma'am.
Slide show कुठं गेली? That's good. Okay. So last time I think I have started with a backtracking. Basic concept of backtracking I have already explained you. Then we have taken the 8 queens, 4 queens, 4 queens मध्ये backtracking कसं होतं I have explained you this one also, right? Then backtracking algorithm. Then sum of subset problem also I have taken. What is mean by a sum of subset? That is a set of n number is given and some total is given, that is m, that is sum of any numbers whose sum is 31. Prepare the subset from a given set. So for example 11, 13, 7 will give you a sum 31, 24 and 7 will give you a sum 31, like that. You can give, given the positive numbers, what is the problem is finding the all subsets whose sum is m. So you have to find the all subsets. So again you have to try the different permutation, form the tuples. So this is what we have studied. Even we have checked the space organization for a sum of subset also last time. Then backtracking, right? Today we are going to study a new problem, that is graph coloring. So what is the concept I will tell you, but graph coloring and where it is used. You will see its use over the period of a time. There are many applications of a graph coloring. Okay, so in graph coloring I will just ask you few things because again these are the discussion problems. For example, okay, what I will do, I will copy this one better. Okay, so this is a 5-node graph. Are you able to see 5-node graph?
Yes, ma'am.
Yes. So you have to use the color, different colors you can use to color the nodes of this graph. What is the condition? The condition is, this is the problem. I have to use the minimum number of color, minimum number. I'm not asking the maximum number. So I have to use the minimum number of colors so that I can color the nodes of a graph such that what is the constraint? Constraint is no two adjacent nodes have the same color. दोन adjacent nodes ना same color नाही पाहिजे. Okay. So there are 5 nodes. You have to minimum. जर maximum म्हटलं तर 5 कलर वापरले. एकाला रेड, ब्लू, ग्रीन, येलो, orange. So if I use the 5 colors, each node will have a different color, right? But here what I'm asking you is use the minimum number of color so that no two adjacent node have a same color. So what will be the minimum number of colors required for this graph? Will it be a 2, 3, 4? ह्या ग्राफला किती मिनिमम कलर सिलेक्ट केल्यानंतर आपल्याला दोन ऍडजस्टंट नोडला सेम कलर नाही यायला पाहिजे. ट्राय द परम्युटेशन. किती कलर्स लागतील? While mark the attendance on a classroom, I have uploaded attendance. So mark your attendance and don't miss to mark the attendance. नंतर शेवटी जर तुमचं नाव डिफॉल्टर लिस्ट मध्ये आलं तर I will not be responsible because we are sending this attendance to coordinator. So if your name comes in a defaulter list, then सगळं ऑनलाईन आहे ह्याच्यात तर आणि काही मॅनेज पण नाही करता येणार मला अटेंडन्स. येस किती नंबर मिनिमम नंबर ऑफ कलर लागतील.
Ma'am, please repeat the complete question once again.
Okay. I want to color these 5 nodes. मला हे 5 नोड कलर करायचे. कंडिशन काय आहे की दोन ऍडजस्टंट नोड ना सेम कलर नाही पाहिजे. फॉर एक्झाम्पल हा जर 1 घेतला तर 1 ला ऍडजस्टंट नोड कुठले आहेत 2, 3 and 4. 1 is connected with 2, 3 and 4. जर मी 1 ला रेड कलर दिला तर 2, 3 आणि 4 कुठल्या पण नोडला रेड कलर नाही पाहिजे. ओके. Similarly, if I color node 2 with some yellow color, then node 2 is connected with 1, 3, 4 and 5. So don't repeat the same color to all these remaining nodes. कळालं? Color graph coloring problem. This is called as a graph coloring problem. याच्यामध्ये प्रत्येक ग्राफचा प्रत्येक नोड आपण एका कलरनी कलर करणार आहे. कंडिशन अशी आहे
So,
की
ma'am, we can have maximum 4 colors, minimum 4 colors. Sorry.
हा 4 colors. Okay, that is what I want. 4 colors. Anyone? Any other answer? 5 कलर घेतले तर होतातच. That is not the thing. I want to use a minimum number of colors. Yes, other than 4 colors आणि काय आन्सर आहे?
No, ma'am.
आणि कुणाचा आन्सर आहे? Will 3 colors do?
No, ma'am.
No?
No, ma'am.
Okay. So now I will come to the problem. Okay, now I will go through this. That is, let G be the graph, M be the positive integer. So we want to discover whether the nodes of G can be colored in a such a way that no two adjacent nodes have the same color. Yet only M colors are used. Okay. So this is the problem statement where graph G is given with some nodes and M is the positive number. So you have to color graph G in a such way that no two adjacent nodes have the same colors. This is termed as a M colorability decision problem. Again, this comes under the what I can call it as a NP problem, NP complete problem, not a hard problem. So this comes as a NP problem, non-polynomial problem, which that is what it is discussed in a chapter 11. Okay, now this type of decision problems are usually NP problems where the complexity is bit difficult to decide. म्हणजे जसे आपले लिनियर किंवा पॉलिनॉमियल प्रॉब्लेम होते इतके दिवस की we can write a loop and we can solve the thing, that is not possible with this problem. These are called as a decision problems. M colorability decision problem. आधीचा कसा होता, मिनिमायझेशन मॅक्झिमायझेशन प्रॉब्लेम होते किंवा अरेंजमेंट प्रॉब्लेम होते. That is not the case. This is a optimization plus decision problem. Okay. So here what we are going to do, we are optimizing in a such a way that minimum number of colors are used. That's why it is optimization also. And we are going to decide. Note that if D is the degree of a given graph, then it can be colored with a D plus 1 color. So this is a standard formula which is obtained. That is, if degree of given graph, डिग्री म्हणजे काय, त्या नोडमध्ये त्या नोडला किती एजेस इन्सिडेंट झाले किंवा त्या नोडला किती एजेस येऊन अटॅच झाले. सो इफ द डी इज द डिग्री ऑफ अ ग्राफ, देन डी प्लस 1 आर द कलर्स. M colorability optimization problem asks for smallest integer m for which graph G can be colored. That is what I asked you. That is, value of m should be a minimum. The value m ची value minimum पाहिजे, so that we can call it as a optimization. The minimum number of colors such that no two nodes have a same color. Now this integer referred as a chromatic number of a graph. So this m is called as a chromatic number. जो काही minimum number येईल, that is called as a chromatic number. जसं आता तुम्ही सांगितलं की ग्राफला 4 colors लागणार आहे. So 4 will be the chromatic number of that particular graph. Remember this thing, this chromatic number is many times asked in a GATE exam किंवा तुम्ही जे काही टेक्निकल एक्झाम देणार आहे ना, त्याच्यात हा बरेचदा क्वेश्चन विचारला जातो. म्हणजे एस्पेशली दिस फॉर्म्युला, रिमेंबर this, that is d plus 1. Many time it is asked if d is the degree. ग्राफ दिलेला नसतो, क्वेश्चन कसा विचारलेला असतो, 3 is the degree of a graph, then how many number of colors are required for a minimum number of colors are required for graph coloring. बरेच स्टुडंट मग सांगत येतात, मॅडम तिथे ग्राफच दिला नव्हता आणि डिग्री विचारलेली, क्वेश्चन चुकलेला. So that is not the case. So this is the formula that if d is the degree of graph, then graph can be colored with a d plus 1. And this is called as a chromatic number. बऱ्याचदा मुलांना ही टर्मिनॉलॉजी माहित नसते. What is a chromatic number? जे especially chapter option ला टाकतात. So that can be colored. For example, actually, if you told me this is the 4 colors, but this graph you can color with the 3 colors. Okay, 1, 2, 3. 3 colors are sufficient to color this graph. It can also seen that 3 colors are needed to color this graph, and hence the graph number is the graph chromatic number is a 3. The graph chromatic number is 3. Sorry, this is not the graph. This is not the graph. Let me wait for a moment. Just give me a moment. That is the different graph which we are going to discuss. The graph is there. I will discuss that too, and that is the 4 is the correct answer. Now, tell me about this graph. Tell me about this graph. How many colors are required for this graph? How many minimum number of colors will be required?
Three.
3. Yes.
Three.
This graph will require 3 colors. Yes. How I can color it? This is a 1.
A and D can have same color, and E and C can have same color. And
Yes. E and C. So this is a 3, and this is a 3, and this is a 1, and this is a 1. Right? So with the minimum number of 3 colors, this can be colored. So chromatic number of this graph is a 3. This is what it is all about. The 3 is the जसं मी म्हणजे हे मी पॅरा रीड केलं मला लक्षात आलं की I have told you a different graph, but this is also we are going to discuss. This requires 4 colors. This is a correct answer. This graph requires a 4 color, and this graph requires a 3 color. So chromatic number of this graph is a 3, and chromatic number of this one is a 4. Now, if you observe the degree of the node, if you observe the degree of any node here, actually for this it was like for many years researchers were thinking that this will require a 4 colors, but over the period of a time, as and when they solve, they come to know that the 3 colors are sufficient to color this graph. Okay, so here few node have a degree 3, few node have a degree 2. So minimum number of colors required are 2. While in this case, if you observe, each node is having a degree 3. Degree 3 means number of edges are connected to this node are 3. 1, 2, 3. Here also number of edges connected are 1, 2 and 3. 1, 2, 3, 1, 2, 3. All nodes are connected with a minimum 3 edges. That's why 3 plus 1, 4 colors are required for this graph. Now how this graph is generated? Again, this same application we can use for a what I can say, coloring the planar surface also. जर plain surface असेल, graph नसेल, the plain surface we can convert it into a graph and then we can apply the colors. Especially हा कुठं problem येतो माहिती आहे? When the maps are given, right? Maps are given. For example, तुम्ही world map शिकला असाल पहिल्यापासून from your school days. If you observe, each two adjacent countries don't have a same color. बरोबर आहे? दोन adjacent countries ना same color नसतो. The countries are highlighted with a different color. The same color may be applied to somewhere the country which is not connected. So for a planar surface also, we can use this graph coloring problem with a minimum number of color. So what we have to do, whenever the planar surface is given, we have to convert that planar surface into a graph and then apply the problem. Okay. For example, this is the same thing 1, 2, 3 जे आता आपण केलं ते. Okay. So for example, this is the map and it's a graph representation. Okay. So this is the planar surface. This one is the planar surface किंवा planar graph किंवा map म्हणूया आपण. This is the map given and this map is converted into this graph. How it is converted? That is, this is the one country किंवा map, one part of a map. Okay. So distinct parts are first identified. This is second is this. For example, this is the, I will cross it. Then I will put the dots on this. So this is the second one. This is the third one. Third area. So each area is a different. This is the fourth area. And this is the fifth one. So each and every part is a different. So what we can do is nothing but we can draw the 5 different nodes here. So 1, 2, 3, 4 and 5. 1, 2. मी मुद्दाम draw करती है so that you can understand how the graph is generated. Directly असा graph generate झाल्यापेक्षा. Now what we can observe, to which other areas the one is connected. So if you observe, one is connected किंवा one कुणा बरोबर area share करायला लागले or one's area is connected with which other area, one is attached to 2 म्हणजे adjacent one ला 2 आहे, 3 आहे आणि 4 आहे. ही 4 ची साइड येते, ही 3 ची साइड येते आणि ही डॉटेड 2 ची साइड येते. So how I can connect? One is connected with 2, 3 and 4. Then
so we can say that shared boundary can be connected directly.
Share boundary. Shared boundary we have to connect. For example, म्हणजे ह्याचा कसं असतं? For example, if I don't see this graph, okay, हा graph जर मी नाही दाखवला, only I have given this planar area and I have asked you that color these areas or color this map so that 2 adjacent areas don't have the same color. ह्याच्यामध्ये तुम्हाला हा मॅप दिला आणि हा मॅप कलर करायला सांगितला such that 2 adjacent areas don't have the same color. So this is a bit complicated map. तुम्हाला त्याच्यामध्ये पटकन नाही लक्ष देणार. So what we can do is nothing. किंवा कम्प्युटरला, आता you are a human being, you can process. But if I give it to the computer, how I can give it to computer? हा मॅप मला असाच्या असा कसं देता येईल कम्प्युटरला? So instead of that, what I can do is nothing but I can convert this map into a graph. And graph is something, the nonlinear data structure which computer can process. Right? The graph is the nonlinear data. That's why data structure is a very important thing. तुम्हाला इवन तुम्ही इंडस्ट्रीमध्ये गेल्यानंतर माझं हे आठवणार आहे तुम्हाला की मॅडम सांगत होत्या की डेटा स्ट्रक्चर इज अ इम्पॉर्टंट. देअर ऑल्सो यू learn how to store the data. In that case, you must have the thorough knowledge of a data structure. Pointers, linear, non-linear, especially non-linear मध्ये trees, graph मध्ये data कसा save करायचा आणि कसा extract करायचा. Okay, so this is the thing where what we can do is nothing but we can convert this planar area किंवा planar map into a graph. ह्याच्यात जे शेअर्ड बाउंड्रीज आहेत म्हणजे त्या एरियाज कनेक्टेड आहेत. म्हणजे 1 इज शेअर्ड विथ 2, 3 and 4. So 1 is connected with 2, 3 आणि 4. Similarly, 2 shared its boundary with 1, 4 आणि 5. So I can mark the 1 to 4 and 1 to 5. Similarly, 3 is connected with 1, 4 and even 2. This is the 2 boundary and this is the 3's boundary. So 3 is connected with 1, 4 and 2. 4 is connected with 5, 3 and 1. 1 already connected at 5 and 2. Similarly, 5 is connected with 2 and 4. So 5 is connected with 2 and 4. So this is how from the planar map the graph is generated. For this problem also for many years from the graph from the map the scientists think or whatever who is solving the problem thought that it requires almost a 5 colors, but when they come to the graph they will realize that 4 colors are sufficient. 4 colors are sufficient to color the graph. Okay. So समजला graph coloring problem. There is a no technical details किंवा ह्याचे algorithm they are mentioned in a book, but those are for a PG student कारण त्याचा NP complete चा concept असल्याशिवाय आपण algorithm नाही शिकू शकत आणि असं ऑनलाईन तर नाहीच. I will not take. So actually नाही पण what is expected from you is nothing but a concept of graph coloring. And how the backtracking is implemented is nothing but usually we don't color again same असेल तर we scratch it and we try the different color. So that the backtracking तुम्ही इवन आता जेव्हा 3 किंवा 4 मला कलर सांगितले तेव्हा तुम्ही 3-4 वेळा कॉम्बिनेशन केलं असेल. So this is a backtracking and again the decision is used. Backtracking problem plus decision problem. Okay. So what is the thing is concept is required. Chromatic number, remember the theory part, chromatic number, degree, d+1 colors and how to color the graph. Graph दिला तर minimum color. किंवा especially ह्याचा थोडाफार descriptive किंवा comparative problem विचारला जातो. The next is a Hamiltonian cycle. The next point in this chapter is a Hamiltonian cycle. Let GV be the connected graph with the n vertices. A Hamiltonian cycle, again this is why it is called as a Hamiltonian, because it is suggested by Sir William Hamilton. He was the actually mathematician who tried to develop or who developed this concept, so that's why it is called as a Hamiltonian cycle. So Hamiltonian cycle is a round trip path along the n edges of a G that visits every vertex once and return to its starting position. In other words, Hamiltonian cycle begins at some vertex V1, then visit all vertices in a graph once and return back to the V1. So where we have used this? कुठं वापरला पण हे? Already we have studied this concept, Hamiltonian cycle. कुठं वापरला?
I'm salesperson.
Huh?
I'm traveling salesperson.
Yes, traveling salesperson. So traveling salesperson is a perfect example of a Hamiltonian cycle. So if the Hamiltonian cycle exists, then and then only you can solve the traveling salesperson problem. Or if they have asked the traveling salesperson problem, that means there exists a Hamiltonian cycle. So there are some graphs where there is a no Hamiltonian cycle also. So you have to check whether first the Hamiltonian cycle is present in that graph or not. Otherwise, you have to check means the graph with Hamiltonian cycle or without Hamiltonian cycle. So traveling salesperson. Yes.
Ma'am, can we say that in this graphs we have to minimize distance and displacement should be 0?
Which one? In this Hamiltonian cycle?
Yes, ma'am.
हॅमिल्टोनियन सायकल मध्ये आपल्याला डिस्टन्स नाही काढायचं, आपल्याला फक्त चेक करायचं आहे की सायकल प्रेझेंट आहे का नाहीये.
मॅम मग ट्रॅव्हलिंग सेल्स पर्सन मध्ये तर तेच करतो ना आपण की डिस्टन्स मिनिमाइज करतो आणि डिस्प्लेसमेंट झिरोला
मी तेच म्हणते ना, ट्रॅव्हलिंग सेल्स पर्सनचा प्रॉब्लेम दिला असतो ना, त्यावेळी कंपल्सरी सायकल प्रेझेंट असतं. त्यामुळे आपण आपल्यात त्याला पुढचा टास्क काय असतो की डिस्टन्स मिनिमाइज करायचा असतो. याच्यात पहिलंच टास्क काय आहे की वेदर द सायकल इज प्रेझेंट ऑर नॉट, दॅट वी हॅव टू चेक फर्स्ट. फॉर एक्झाम्पल मी 2 ग्राफ दाखवते तुम्हाला. ओके, अगेन just a minute, just give me a moment. Yes, are you able to see the two graph G1 and G2?
येस मॅम.
Now tell me the cycle or आता ह्याच्यामध्ये तुम्हाला ग्राफ मध्ये वेट्स नाही दिलेले एजेसचे, बरोबर आहे. त्यामुळे तुम्ही मिनिमम मॅक्झिमम तर काही करू शकत नाही. जस्ट टेल मी द टूर फॉर ऑफ सेल्स पर्सन इन G1 and tell me the tour of salesperson in a G2. G1 साठीची टूर सांगा आणि G2 साठीची टूर सांगा.
Ma'am, G1 मध्ये 12876541.
एक मिनिट एक मिनिट एक मिनिट 12876543.
431.
What about G2?
I need G2. Cycle is not present.
Yes. In G2, the cycle itself is not present because you try anyway, you have to visit the node twice. जे 1 2 3 4 म्हटलं तर नाही 1 2 3 4 2 5 1. So you have to visit this node 2 twice. Then and then only it is possible. But our condition is you have to visit the node only once. So in this case, the Hamiltonian cycle is not present. So cannot successfully execute the traveling salesperson also. Even traveling salesperson मध्ये if you observe or मी जर तुम्हाला त्यावेळी पण सांगितलं असेल salespersonचा पण algorithm बघितला नव्हता किंवा salesperson again comes under the NP problem because that is also a decision problem. The same thing Hamiltonian also the part of it and Hamiltonian here what we are going to do again here we are doing the backtracking 1 2 3 sorry 1 2 3 4 and again no root to 5 again go to the 2 then no that is not possible so again backtrack the thing so what we can try is 1 2 5 again 2 so that means there is a no cycle present so it is a part of a backtracking plus it is a part of again a decision problem so again it comes as a part of a NP problem. Okay, so this is again concept, just a concept of a Hamiltonian, no algorithm of a Hamiltonian. Okay, so only theory part of a Hamiltonian. So this is all about today's lecture. Here we have studied the graph coloring. Even I have updated slide just now. That is even I have added the state space for M coloring. That is how the M color will work like X1, X2 and X3, three colors. So what are the adjacent possible color? Even X2 and X3 if you have one color, no, that is not the possible. So 1, 1, 2 is not possible. Again 1, 2. Likewise, you can try a different combination. So number of nodes are 3 and colors are the 3. So this is the state space tree for that. And here the nodes are 4 and colors are the 3. So this is the state space or graph for that. So this is I have updated the presentation and I think this completes your unit 5 backtracking. So what we have studied, this is a smaller unit. We have studied is nothing but a right from concept of a backtracking, then implicit constraint, explicit constraint, various definitions, then problem, it means problem, some of definition like I have covered the what is mean by a problem state, answer state, state space tree, organization, solution space, all these concepts we have studied. And what are the problems which we have studied under this is a queens, sum of subset, then graph coloring and Hamiltonian. Okay, so this covers the unit 5. Tomorrow I will start with a unit 6 that is nothing but yes what is where is your syllabus. Unit 6 is a basic traversal and search technique. Out of that I think technique for a binary trees and graph you know but still I will revise the techniques like binary tree traversing चे techniques कुठले आहेत? मी ऑलरेडी शिकलेला आहे प्री ऑर्डर पोस्ट ऑर्डर आणि इन ऑर्डर and binary tree and graph both are the non-linear data structure. Linear data structure we can access one after another but non-linear data structure you have to find the traversing methods. So these are the two traversing methods which we are going to study for non-linear data structure trees and graph. So binary tree साठी in order, pre order आणि post order. आणि ग्राफसाठी DFS आणि BFS, breadth first search आणि depth first search. Hopefully both you have studied. Still I will revise it. And then and or graph, connected component, bi-connected component is the new thing. Now connected component and bi-connected component are application of BFS and DFS that I will teach you. And then comes there is an introduction to NP hard and NP complete. Okay, so this is the review of unit 6 which I am going to cover. I will try take lecture tomorrow too. On Thursday I will post the timing for